Precipitation reactions. So now we've discussed how we can figure out which ionic compounds are soluble or not. Have you ever seen this kind of stuff at your house? This white, scummy stuff? The water around here is fairly hard. And when we say hard water, what we mean is it's got calcium and magnesium ions dissolved in it. It's got a lot of dissolved ions. These calcium and magnesium ions will react with soap and form this gray curdy substance, also known as bathtub ring. That's the ring that gets left on the bathtub. And this is also what makes your clothes, your white clothes especially, start to get gray after a while, is because the calcium and magnesium ions in the water are reacting, and then this soap, this curd stuff gets deposited on your clothes, and that's kind of gross to think about. Laundry detergents have sodium carbonate in them. Well, and sodium carbonate is soluble, because sodium compounds are all soluble. So the laundry detergent dissolves in the water, and now you've got sodium and carbonate ions in with your clothes. The carbonate will form insoluble compounds with calcium and magnesium, causing them to precipitate out of solution. There's not enough that you're going to notice that, oh, there's this weird solid in the bottom of my washing machine. That's probably from the stuff you left in your pocket. It's not calcium carbonate. Unfortunately, if your water is really hard, the sodium carbonate in the laundry detergent isn't quite enough to really take care of it. I don't know about you, but I use laundry detergent and my white clothes still get gray. It's an endless frustration, which I got around by just not wearing white clothes anymore. But these are the reactions. So calcium ion dissolved in the water encounters carbonate ion dissolved in the water, and they form an insoluble compound, precipitate out of solution. So these are called precipitation reactions. You have two solutions, and when you mix them together, you get a precipitate. And this reminds me of weather. We've had a lot of precipitation lately, right? Things falling from the sky. There's water falling from the sky. It's so wonderful. We hadn't seen that for so long. This is a lot like, this looks more like yellow snow, which you should never eat yellow snow. But it's a solid that's forming. Oops. Up here we have a clear liquid, and in this flask we have a clear liquid, and when we mix them together, we get a solid forming. We saw this in lab on Monday when we mixed some things, right? It was clear, and all of a sudden it got cloudy, and colors changed, and all kinds of cool stuff happened. So here we've got an illustration of this solution. This is potassium iodide, which we know from our solubility rules is soluble. So the iodide ions and the potassium ions are separated. They're swimming around in the water. Here we have lead-2 nitrate. Ions are separated. This is nitrate compounds are soluble. When we mix these two together, the lead and the iodide ions, when those get together, they form a precipitate. They are not a soluble compound. And so they will settle to the bottom eventually as a solid. This is called a precipitation reaction, and the solid that forms is the precipitate. We can predict what's going to happen in a precipitation reaction. So this is that same reaction. Here we've got the potassium iodide and the lead-2 nitrate, and we look at the ions that are present in the individual solutions. We've got potassium ions and iodide ions. We've got lead ions and nitrate ions. We know that lead with nitrate was soluble and potassium with iodide was soluble. So when we mix them and we get a solid forming, it must be a new combination. There's two possibilities. The lead, why do I keep doing that? The lead could be with the iodide, or the potassium could be with the nitrate. These are the two possible products. We have switching of partners. So I think of these beakers as being parties. And I've told you before that the metals are masculine in Mrs. K's chemistry land. It's not nearly as fun as Disneyland, but it's close. And the non-metals are feminine, non-masculine. So here I have a guy and a girl, and here I have a guy and a girl. And they're not, you know, married or even exclusively dating or anything. They're just friends or hanging out together. When these two couples get together at a party and they're mixing, and potassium sees nitrate, like, oh, hi, how are you? Nothing really happens. When lead sees iodide, there's this really big attraction, right? He's like, oh, wow, this is what I've been looking for. There's this chemistry that happens, and this forms a solid, okay? And they're no longer mingling in the party. They found a couch in the back room, and they're necking, okay? They precipitated, they moved out of the solution. You like that? The exact details of it change every semester. I never know what it's going to come out. Anyway, so a reaction occurred. Why didn't potassium and nitrate do that? There's just not the same kind of attraction. And just like with relationships between people, you know, why do two people get along and two other people don't? It's complicated, okay? And so we can't just say, well, this is a positive ion, that's a negative ion, they should form and precipitate. No, they don't. And we just look at the rules to predict who's going to get involved with each other. Sometimes you can mix two aqueous solutions and nothing happens. There's no chemistry. If we mix potassium and iodide with sodium and chloride, these are two soluble compounds, we mix those two together, nothing happens. There's no chemical reaction. There is a physical change that has occurred because we have mixed them. They weren't mixed before, now they're mixed. Something has changed, but it's not a chemical reaction. Because potassium and chloride are just not that attracted to each other. Potassium chloride, you look at the solubility rules, potassium compounds are always soluble. Look at sodium and iodide, sodium compounds are always soluble. Nothing's going to precipitate. So you don't always get a precipitate. We need to learn how to write equations for this, and I think we'll talk about this next week.